Hey guys, time for a progress update on the Predicta Siesta. I've been slowly but steadily replacing components on the main board and starting to relocate some of the electrolytics onto the board. It really is an amazing coincidence that they have some unused pads where these caps can go. So that's the boost filter cap. A little hard to see, but underneath that cap there was a square with a hole in it going to the boost, and there's a ground point nearby. There's some similar ones over here. I don't know if they were from revision changes or what, but what it comes down to is there are unused holes on the board that correspond to some of the points where filter caps are needed. For the grounding, yes, I did have to double up and have two components go into one hole. But other than that, it works out great. I am also replacing the sockets. So in the last installment I had just started chipping up this one for the vertical. I have replaced it. And I figured if I do that one I might as well do the rest. So I had taken out this guy. And I've also replaced the 7-pin tube for the sound IF. Now this one is going to be a little bit, well, let's just say I was trying to find replacements that not only looked the same but had the same functionality. So in this case, a socket with a shield on it. Now the original shield they had was kind of cheap, made out of just rolled up sheet metal with a seam on one side, and they put it down over the tube socket, something like that. I was hoping to find one that was more integral like this, and this has a nice slide down, but I couldn't find any. So I'll use, again, one of the sockets like this and just have to reuse the original shield. Problem with these shields that don't slide down is they can be really tough to get the tubes out. In fact, I remember in particular having trouble getting that tube out because only a little bit of the glass protrudes from the top and there's just not much to get a grip on. These aren't too bad on the tuner, or I should say that the tuner has the slide down shields I'm talking about. So you see when you slide them down, then you can have more to grab on. I also want to point out some other things. There are some oddball component values. So if you're thinking of trying to do the same thing in shotgun, all the parts, just beware. I've mentioned previously that this capacitor is a .0015, needs to be rated for 1,000 volts or better. And some of the resistors are a little bit odd. We've got a couple 1.5 megs, a 1.8 meg, a couple 12 megs. The Vichy series, these brown ones I've talked about numerous times, they only go up to 1 meg. So anything above 1 meg, you've got to look for alternates. That's why these are different colors here. And when you get into 12 meg, I can only get carbon film. I wanted to get metal film. It's a very minor point in this application. You're not going to notice a difference, probably. But carbon comp especially, and to some extent carbon film resistors, do drift in value with temperature. So if it was using a circuit where there was an RC time constant, say in a vertical circuit, as the set warmed up, potentially you could use vertical hold. I don't think the resistors are going to drift that much, but metal film, metal oxide are very temperature stable. They also, I believe, have less noise. So it's kind of an odd topic, but essentially like the electrons flowing through a device kind of bump into each other in the atoms, and I'm probably oversimplifying things, but they can make a certain amount of noise. Again, in this application, I don't think so. If it was a super high impedance, very sensitive, high gain piece of instrumentation, yeah, it can make a difference. In an old TV, probably not. But that's why they predominantly make these days, is what I was getting at. Yes, they do still make carbon comps. You can get them. They do have some characteristics that are desirable in some applications. For example, they can withstand pulses better. these will tend to blow out if they get a current surge, whereas carbon comps can kind of suck it up and dissipate it, so to speak. So that's why I believe why they're still made, but be prepared to pay maybe $1 a piece for them, and you may have trouble finding 2 and 3 watt. But half watt, yeah, they do seem to be fairly available. And as far as tolerance, there's a range on these boards. Some of them have no fourth band like this guy, meaning it's 20% tolerance. So it can be pretty far off in value and still be acceptable. Tube circuits are very forgiving. This could go up as much as probably 300 plus K, and it'd make very little difference in the circuit. The majority are 10%, and there are a few 5%. Those would be I'd be a little more wary of. For example, this is a 4.3 K resistor. It's a standard value in the 5% system, but it's not commonly used. And they did spec out 5% for that one, so I assume it's in a little bit more of a sensitive circuit. Something like these 12 mag are used in the AGC. If it drifted up to 14 mag, 15 mag even, I don't think there'd be any noticeable difference. But again, as I've stated, once you've got the board out, if you've got the means, you've got the parts on hand, why not? And yes, when I have measured these, they're virtually all off. All have drifted up in value, anywhere from 5 to 30-40% high. And also, as we've seen, some of these resistors got pretty hot and pretty toasty. So here's an example of one where I kinked the leads to provide a little bit of physical support and get it up and off of the board. And over here they had a sand power resistor with these ceramic standoffs. I reused them and put in a Dale resistor rated for a higher wattage. In general, I use higher wattage resistors in the original, so these may look small. These are 1 watt resistors. I'm using 1 watt in replace of the half watt, and 2 watt in replace of 1 watt. And if I have them, if I can, I'm using 3 watts in place of 2 watt. And this was a 7. I think I got 13 watt on that guy. Also, thank you for the suggestions on where to get octal sockets. Yes, they are available from a range of suppliers, several different styles. I was not able to find one, though, that was exactly the same as these. With plastic, with the leads that come straight down like that, some of them kind of come out to the side and then bend down, or, well, anyways, there are a number of different styles out there. I ended up going with some that I hope will work out. With the global situation being what it is, I wanted to find a supplier in the U.S. A lot of the ones I saw were coming from China, and I don't know when they would ever get here. Hopefully they'll be here next week. Meanwhile, I'll do what I can on this. I also want to start doing work on this, namely clean it. I'm going to completely unmount the vertical output transformer. I think I've already taken the screw out, but I want to unattach the wires, even though there are a number of them going to it. Because I don't particularly want to submerge that, and I want to get the flyback off and pop the IF shield off, and then I want to get this in the utility sink and do the simple green job on it again, or like I did on the other components. So hopefully we'll get the whole chassis looking like this. The flyback does not look difficult to remove at all. There are a couple metal tabs it slides into in the chassis, and I think there's only a single 1/4-inch screw somewhere down. Just one down there. That might be it. I'll have to disconnect some wires. I can see them running off here because this is also does double duty as the yoke socket. So they're coming down in here, and I'm sure they're going around this way and all the way over. So I might be best off leaving all the wire because they're going through. No, that goes. Yeah, that is part of the flyback thing. I might just disconnect them from the socket. I might just replace all the wires. But I don't particularly want to run new wires through the whole chassis. But yeah, it'll give me a nice sense of satisfaction to get this whole thing clean too. Also have the control harnesses to deal with. I'm not crazy about submerging the controls, so perhaps I'll put those over the side of the sink. And then drying this out is going to be a little bit more of a challenge. Well, perhaps it'll fit in the oven. Power transformer. I really don't want to unmount that. It's pretty well sealed up top, but there is an opening down on the side here in the bottom where the wires go in. And I've seen other suggestions on how some of you dry these out and do it for much longer periods of time. And I also got a suggestion how I can run my oven at a lower temperature than 175. So, it has apparently a dehydrate mode on it. I never read the service manual that came with our oven when we bought this house, so I've just kind of experimented with the controls to figure out what it can do. So it might be time to read the manual. There is one last thing I wanted to talk about with this main board. If you recall, I had weak sound. I tried tweaking the sound IF and sound. I'm not sure if it's a ratio detector or exactly how this works, but there's a secondary sound transformer. I want to make sure those transformers are good. I noticed the core on one of them was sticky. I didn't realize at the time that this transformer, which I've removed, has two cores, one at the top and one at the bottom, and the bottom one seems to be stuck. I want to check the primary and secondary resistance on this and see if I can free up that core. The 21-inch Predictas use a quadrature sound type system with a gated beam tube, a 3BN4. This does not. Well, I shouldn't say that. I guess they do call it a quad coil, but it does not use that gated beam tube, which I believe was created by Zenith. There is also a couplate in the sound circuit, which in the past I've never messed around with, but that reproduction kit I got does include one for N4. Why they would have a couplate with just two components inside of it, I don't know. I can't imagine what big cost savings I got by doing that, but I will be replacing it. So this is the transformer we're looking at right now. Primary, secondary. Secondary has a cap in it, primary doesn't. We should have 3.4 ohms on one side and 4 ohms on the other. So let's check that out right now. Now notice there's 5 leads coming down out of the bottom. But this extra one here in the middle, I can see doesn't have any wires going to it. You can see little wires coming up around the bottom of the others. I think the way the numbering goes is this is one side. Good. 3.4 ohms. And on the other side, 3.3. Alright. I'd say that's good. I'm not going to quibble over a few tenths of ohms. So, core. So here's the kind of tool you use. A plastic with a hex on the end, and then the shaft gets smaller and round after about half an inch or about a centimeter. So if I go to the top core, it turns. If you keep going down, you reach a point where you can kind of freely move it, and then it meshes. So right now I'm kind of in between the cores. You can rotate it out into the bottom core. It does not want to turn. Now with it out, I can see it from the back side. I can peer down in there. You guys probably can't see that. But you can see two hexagonal cores with a bit of a gap between them. I can try going in from the bottom. Still no love. If I keep turning this plastic is not all that sturdy. I think the tool's going to break before the core will do anything. I know there are tips and tricks on how to free up a core. I'm going to go review those because I've never had to deal with it before. I also think I'll take this cover off so you can get a better look at what's going on. It's soft aluminum, and they have little tabs that they bent over. It's holding it on. If I straighten those out, I should be able to get this off. So let's see what's inside. I'm going to straighten these shield tabs out a bit too. Absolute worst case scenario, I could salvage another one from another set, but I'd rather not. I don't have to. So it's interesting. So it's rather than a transformer having the secondary being wound over the primary, they're actually separated vertically. And then you've got a core in the top and bottom, and you can move those cores independently up and down. Both that affects both the resonance of each coil and I imagine also the transferring of energy from one to the other. Unfortunately, we can't see that bottom core because it's inside of a tube. I can't really heat this up. This is cardboard and wax. Although, maybe I can. Because if there's wax coating on this, and it appears there is, heat would soften the wax. But I'm doing it in a very controlled manner. I don't want to roast this coil, so I'm going to get a heat gun and put it on low. Let's see what that does for me. And this was sticky before I gave it a bath, so that didn't have any effect on it. You can see the wax going. Kind of shiny, indicating it's melting. Hey, what do you know? That freed it up. So there must have been some wax that got down in there. Or heating it up expanded things a bit. And there's the core poking out the bottom. Well, that was easy. I'll keep working and make sure as it cools down I can continue to turn it. And of course I gotta put it back together and remount it. There's the top one. Nice. Obviously I'll have to do a realignment on the sound when I get this all back together. I contemplated what to do with this chassis for a while. I looked at what was involved in unmounting the flyback, vertical output transformer, controls, and so on. And, well, one of your comments pushed me over the edge to just go ahead, put it in the utility sink, and spray it down and wash it down. That comment was about my oven. He had seen my home tour video from ages ago and was a very careful observer, and he noticed what kind of oven we had. And he had had the same oven, and he gave me a tip about it, which was, if you hold down the convection bake button for more than 5 seconds, you can get into dehydrate mode, which lets you dial in a temperature. Defaults to 140. You can go down to, I think, to 100. And then he said your oven originally came with a dehydrate bowl or something like that, which included a wood block to prop the door open. So I just stuck a chopstick in there and put this thing at 140 with the convection mode and let it sit for about an hour. So what that does, lower temperature, so the wax, like on the flyback, didn't melt off. And convection mode circulates the air, and having the door propped open lets the moisture out. So maybe it was in there for about 2 hours. It was in there for a long time, and it's been off about an hour. The transformer core is still a little toasty. And I think we'll just go with that and see how it turns out. I was also lazy. I didn't take this cover off. I should have. So I will be taking this off and probably the IF board out. I expect it's still a bit dirty under there because I really couldn't circulate the cleaning solution and water down in there. But the rest of it is pretty respectable. It's not perfect by any means. It looks pretty good underneath. One nice thing about this technique too is that it doesn't ruin the labels. I'm kind of surprised. In some cases, yeah. Like this cap on the main board did lose some of its printing along the replacing anyway, so I don't really care. But generally speaking, like on this transformer, that's still perfectly legible. Ink didn't come off, in other words, so that's cool. But still a bit of a tinge on this because I couldn't get in there and really scrub it. I didn't want to disrupt all the wiring and so on. Speaking of the wiring, it is a bit cleaner. So all in all, assuming this stuff really dries out, because I've heard some of you guys do this for many hours. I don't quite want to take up the oven for that long. And considering that the tuner and this board, I was only had them in there for 10 minutes, I figure a couple hours or so on this should have done a pretty good job. And I was kind of careful with the power transformer. There's a hole down here for the wires on the side. I was careful to not tip it that way or like force water up into it. So I think we'll be all right with that. So again, I'm waiting for an order to come in for the octal socket. Until that happens, I can't completely finish this, but I'll do everything I can with what I've got on hand. Finish repopulating this board as much as possible, and then I'll pop the cover off this and show you guys what's under there. Alright, what the heck, I'll just do it right now. I'd forgotten how easy it was to do. There are several bent over metal tabs down here. All you gotta do is take some pliers and straighten them out, and that cover pulls right off. Also want to mention this chassis is cadmium plated. That's why it's got that yellowish discoloration to it. It's not just nicotine and so on. That is cadmium sulfide, I believe, makes it yellow, whereas cadmium oxide makes it whitish. And there were some postings about the potential reaction between simple green and cadmium. Doesn't really seem to be the case. That's pretty much how it looked before I started, so I don't think that the simple green promoted any further corrosion in it. And yes, I know it's somewhat toxic if ingested and if inhaled. I wash my hands after I handle this, and I'm not really concerned this stuff is not becoming airborne while I'm working with it. And I'm not sticking my fingers in my mouth or anything like that, so I don't think it's really anything to be too concerned about. I think it's about ready to come out, but there is a bit of coax that's crimped on the end here, the metal tab. That's what goes over to the tuner output. See if I can bend that back a bit. Slip out the wire. There we go. And there it is. Not terribly exciting. So as I said earlier, there are no paper caps. There certainly are carbon comp resistors that may be out of spec, but otherwise ceramic caps and coils and some trimmer caps. To get the board out, same deal. Stakes you have to undo, and some wires, but there's only a few. I think there's only 3. That's for the filament power and B+, and I think AGC bus. And then of course the output, which I do believe is this wire here. It goes over to the main board and has a sound and video on it after the detector. So I'll be popping that out at some point, but I'll finish the main board first. In fact, I'll get the main board done and put it back in and rewire everything and power this up again before I bother doing anything with this, just to make sure everything's working right so I don't compound potential problems. I drilled out the rivets holding the vertical linearity control in place, and I think I found the problem. It's not supposed to look like that. So it's a wire wound control, one end of which has torn loose, and the center contact lug was going to this, which is just broken off. So I think there was more to this at some point. So I will endeavor to salvage one from another set. I've got a spare chassis in storage, so I'll have to get to our storage locker and dig it out, and I'll also try to straighten this off. This whole plate got bent. One thing that made this a little bit easier is the, where is it? The part that connects to the CRT detaches. So this would normally be mounted up like this. That's what the CRT plugs into. Most of the wires go to the board, so with that out of the way, this comes right up. There's just one attached over here, so if I disconnected that, this whole piece would completely come off. And I'm kind of toying with the idea, since some of these wires are in pretty crummy shape, is to replace some of these wires. I notice this one looks a little bit different. It's got a plastic sleeve over it and kind of a metal tube on the end. This is for the electrostatic focus on the CRT. They note in the service info that there are a couple points where you can attach it to this board. You can see it down here. CRT screen focus. I think you can go either to that pin, and there would be another one somewhere. I think that guy down there. Generally, there are two potentials. Usually you go between ground and a few hundred volts. I think that says, what, plus 400? So I imagine you pick one of those two, you try them both, and you choose the one that has a better focus. And this one says a sound test post sticking out there. I'm kind of curious what that's about. Since I've got poor sound, maybe that will aid me in diagnosing this if after I put it all back together I still have sound issues. Continuing to make steady progress on the board. I expect to have all the bits that I can replaced soon. I've done three of the tube sockets so far. And something else I want to do. So, you see, I got two electrolytics mounted on here, and I know there's already a spot for the third, just like I did on the previous 17 sets I've worked on. But what I haven't done in the past is found a good place to put these two. So those are both 20, well, originally 20 microfarad. I'm using 22s. Now, one of them needs to go to this. That horizontal B+. So the voltage comes in there. Or actually, I think that's where, well, that's where it went to the original cap. So it snakes over to that couplate, over to that 180K resistor, and the other way to that resistor, and also goes over to that horizontal ringing coil. So somewhere in there, I want to put a cap between that line skirting around the perimeter of the board and ground. Now that stake that bends over right there, that is ground. However, I don't want to put the cap right next to the horizontal output tube. That thing gets pretty hot. So I'm thinking maybe more in this area, or perhaps in here, or even way over here. Just would kind of like to get it close-ish to this area. Put this down for a moment. Originally the cap would have attached here, and it ran around the board, and the filter cap sat over here. So anything even remotely over in here is a lot better than the situation was before. My point being that the capacitor is there to provide bypass for this circuitry. So putting the capacitor near it will help the circuit to function better. Here's what I decided on. I need a cap that goes between that yellow line snaking towards us and ground. Well, it turns out that this metal frame on these two potentiometers is grounded. Let's flip this over. It turns out that that yellow path is not entirely accurate. It's this here, and then this is ground, so I need it to go between these 2 points. And this is the type of capacitor I'll be using, one identical to this. The leads come pretty close together, so I need it to go just like that. So I'm thinking if I drill a small hole about here, and one over here, that'll work out. I could probably even just shove 2 leads through this hole, which I've done in some other instances. In fact, yeah, I think I will do that. The less holes I drill in this thing, the better. I could probably even squeeze the negative lead through that slot there, if I was really so inclined, but I think I can do a little bit neater job than that. So I'm going to reuse this hole and drill a small hole right about there. And that should take care of this guy. Here's how that capacitor ended up. Nice and neat, not doing anything that gets particularly hot. And I think that'll work out just great. Now we need to put another one on the audio B+ there. So this normally routed over to the capacitor that was over here. Well, this is where it's needed on these audio output tube. So we've got a stake, we've got a tube pin, we've got a hole that goes to a 680 ohm resistor. I got the replacement ready here to pop in, and a ceramic cap. So not a whole lot to work with. Well, on this board, as in other ones I've done, there's some unused stuff here. There's a hole drilled through the board. There's something that says WR1, and there are 3 squares with holes through them that aren't going to anything. There are no components mounted there. It's probably from a previous revision, and they just aren't used anymore. And let's flip it over. Well, one of the unused pads is going right to ground, and the other 2 are going to each other, but nothing else. So what we can do is take our capacitor and go from like this, so the grounded side goes in this hole, put another one in one of these 2 holes, and then take the other hole and run a wire from here, and I'll just jam it in here next to the resistor. Put 2 leads into one hole, and that's that, which leaves one last cap. Alright, so we took care of 1, 2, 3, 4. We got 5, 6, 7. There's one more left. And what is that one? Well, let's take a little peek on the schematic here. So this would be part of E2. E2 is a big old 4-section cap that had been down in here. So part of it is an 80 microfarad cap that we replace with an 82. And let's see, that goes to the 275 line, which goes up this way, and then through a 3K 7-watt resistor. It's this part of chassis wiring. And then we've got the plus 140 volt bus on the other side of it. In other words, that's a dropper resistor to cut down the B+ voltage. Go over and 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 over. E2, section 3, 20 microfarad 350. That's the last one we've got to replace. Well, here's the 82, and here's that power resistor, so we just need to put a cap on the other side of it. So in other words, there's a cap on either side. Capacitor, resistor, capacitor. And hey, we got a lug here, we got one going to the chassis right there. Bam, we stick the cap right here, we're done. This resistor will dissipate some heat. This cap is a bit off to the side, so I'll take the other one and kind of shift it over this way as much as I can. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So a little bit of ingenuity, we've replaced all of these. Freed up space, eliminated some wiring. Is it sacrilege? Perhaps to some. These are mass-produced sets. They weren't done with hand-to-hand wiring. There's a lot of them around. It makes a nice, neat job. Maybe it'll confuse somebody a little bit down the road. I'm okay with it. I am going to replace this resistor at some point, so I just kind of tack this guy in, and same with this one. I'll do them a little more neatly. That leaves last few parts to replace on this board, and when the sockets come in, I'll replace those. Got to replace the linearity control, redo the wiring. That's going to be it for this video, though. I'll probably pick up in the next installment when the octal sockets arrive.